Hello, ladies and gentlemen. Today we're going to be talking about trigonometry and just an introduction into trigonometry and what it is. So you're going to need a pen or pencil and your notes. We have some slides that you're going to have to take notes on, and that's towards the end. So make sure you watch the entire video so you're listening to the first part, and then on the last couple slides, watch for that pencil in that corner so you can take notes. No foldable needed. Okay, so today's essential question or key question is what is trigonometry and the ratios that we call trigonometry and where did they come from? So that's what we're going to be talking about in this video. Before we can talk about trigonometry, first we have to talk about right triangles. And right triangles are going to be the basics or the foundation of our trigonometric ratios. So right triangles are really nice as far as real world applications and being able to use relationships in right triangles to find missing parts of the triangle. So we're going to notice a couple nice attributes that help us in real world problems. The first one is the Pythagorean theorem. In right triangles, the Pythagorean theorem helps us find missing sides. Remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. And when we have two side lengths on a right triangle, we can always use this formula to find the third one. The second nice attribute that we've been talking about as of late are the two special right triangles. So the 45-45-90 triangle and the 30-60-90 triangle. So those special right triangles have cool side length relationships. And in this case, we only need one side length in order to find the other two missing side lengths because we've established those shortcuts. The third nice attribute are that right triangles are similar if they have a pair of congruent non-right angles. So I'm going to draw that over here. If we have a right triangle like this, and let's say this angle is 20 degrees, and then we have another right triangle, same shape, just smaller, right? That's what similarity means. It's just a smaller version or a bigger version of the original. And so we know that this works because of just the angle-angle similarity way back from last unit. But because they're right triangles, we already know that we have one angle that matches, the 91, the 90-degree angle, the right one, silly. And then after that, we just need one more pair in order to get two. And then once we have two, we automatically know, because the sum of the interior angles of a triangle is 180, that the other angle, or the third angle, is going to have to be the same or congruent. So here, if we have 90 and 20, the third angle would have to be 70 degrees on both of them. And as soon as we have all of the angles congruent, we know that the two triangles are similar. So these nice attributes have been slowly leading up to certain patterns. And mathematicians noticed that these patterns emerged. So someone in or around India a long time ago noticed that these patterns emerged when you have two right triangles with the same base angles, which is just what I drew on the last slide. So we had this right triangle with the 90 degrees and 20-degree base angles, remember, and one's smaller and one's bigger than the other. So the ratio of certain sides in the same triangle remained constant with other right triangles that have the same angle. And these are the patterns that we're going to talk about that started all of trigonometry. Let's consider these two right triangles. So we know that they both have a 90-degree angle, and then they also both have the 30-degree angle, or that acute angle on the base leg, right? So we know by angle-angle similarity that these two triangles have to be similar. And what we've always done in the past is we wrote the hypotenuse over the hypotenuse, found that fraction reduced, and we compared that to the short leg over the short leg and the long leg over the long leg and made sure that it was the same ratio. So we used to compare from the smaller triangle to the bigger triangle and found scale factors, right? But what people noticed, the people in and around India noticed, is they started forming relationships within the same triangle. So for instance, they were looking at this 30-degree angle and they said, what if I took the short leg, or the side opposite that angle, over the hypotenuse? In this case, it'd be 4/8. Let me reduce that, I get 1/2. Now let's do the same thing for this 30-degree angle in this right triangle with different side lengths. Let's do the short leg, or the leg opposite the 30-degree angle, which is 12, over the hypotenuse, which is 24. And they noticed that these relationships and these ratios stayed consistent even with different sized triangles because they're similar triangles. So not only do they have a similar scale factor, they have these relationships. And we could do it for another two pairs of sides. So let's say in comparison to in relation to the 30-degree angle, the side that's adjacent to it, which is 4 times the square root of 3, all over the leg. Let's do opposite of it, which is 4, and that's going to reduce down to just the square root of 3. And let's look at this 30-degree angle on the bigger triangle again, and the side that's adjacent to it, so 12 times the square root of 3, all over the leg opposite of it, which is 12 again. So we did the long leg over the short leg, and this also is the square root of 3. So they noticed that these relationships were happening, and sometimes, like the first one we did, it came out to be a pretty clean number, 1/2. And then other times it became to be an irrational number, like the square root of 3. So in any case, they started realizing that these relationships stayed consistent in similar triangles, or triangles that have the same angle measures. So let's see where that takes us. Where these relationships take us is what is known to be trigonometry. So that is the branch of mathematics that studies relationships involving sides and angles in triangles. So get that definition into your notes, and notice that we have the pencil on our page starting now. So get your notes out and write this down. Trigonometry is used to measure precise distances in math, science, and technological related fields. You guys, I cannot emphasize enough how important trigonometry is in your math world and how important this is going to be for calculus. So if anyone's going into engineering, astronomy, architecture, aviation, military, land surveying, etc., that is all trigonometry that you're going to need to know. But it is also widely used in other fields like theater arts, digital music, music theory, and design. Trigonometry is a huge math field, and this is just the beginning. The last thing you need to write down in your notes are the 3 basic trigonometric ratios, or trig ratios. They are called sine, cosine, and tangent. And when I see you next, we'll be talking more about what they are and what those relationships are in class. So what the value of the trig ratio depends only on the measure of the acute angle, not on a particular right triangle used to compute the value. It's just the angle in the right triangle. And this means that it does not matter how large or how small the triangle is, the ratio will always be consistent in each triangle that is using the same acute angle. So I want to thank you for taking good notes today, and I shall see you soon.